Okay, in this problem, I've got water, and I want to find the specific volume for two states. So let's start with this first state where my pressure is 10 megapascals and I have a temperature of 485 degrees Celsius. Okay, so I want to use that to figure out the specific volume. So I go into my table. The table I like to start with is my saturation table for pressure, which is table A3 in the book. Make sure we're in the metric because that's what our units are in for this. Okay, so I'm at 10 megapascals, which is actually 100 bar, which is way down here. Okay, so at saturation, right, pressure and temperature are linked. So at 100 bar, my temperature is 311. Okay. However, my temperature is at 485 degrees Celsius, so I'm above saturation, which means I am a vapor. So I'm going to go over to my vapor tables, table A4. Now I'm going to go to 10 megapascals, which again is 100 bar, 10 megapascals. And I notice down here I've got my temperatures, and you can see I've got 480 and 520. I'm at 485, so I'm, approximately, well, we'll figure out how far between that, but 5/40ths, maybe 10% or something. So that means I'm somewhere in between the 0.031 and 0.033. So I need to do what we call interpolate, where we basically just assume it's a straight line between those 2 points. And I want to figure out what's in between there. Okay? So using those values, okay, to figure out that volume. Okay? So I'm going to do it this way. I'm going to set up a couple of ratios. Okay, the first one will be my temperature ratios, which will be 485 minus 480 divided by 520 over 480. Right? Because what I'm basically doing here is finding basically how far in between the two temperatures I am. Right? Because the two temperatures in my table are 480 and 520. I'm at 485, so I'm basically taking a ratio. Hey, how far in between these am I? And I got to be the same amount in between those two volumes, right? So all I do here is I line up my volumes with my values here, right? So my unknown volume V corresponds with the 485. That's what I'm trying to solve for. Okay, at 480, my V was 0.0316. And I divide that by what my V at 520 was, which was 0.03394. And then I subtract off that same 0.0316. So I set up my ratios like this. So I've got my temperature ratios, my volume ratios, and basically I just do algebra. I'll let you do that on your own to calculate what the volume is at that specific set of properties, that specific pressure and temperature for water, and I get an answer of 0.0319, and that's cubic meters per kilogram. Okay, so that's how I go through and calculate and interpolate for that one. Okay, so let's go on to the second one where I've got 80 degrees Celsius and a quality of 0.75. So now I know I'm in saturation because of this 0.75. So I go to my saturation table for temperature because I know my temperature. That is table A2. Okay, here's the first page. Okay, but I got to go to 80 Celsius, so I go over here. So at 80 Celsius, you can see that my specific volume are between these 2 points right here, which is the way this is written with the volume times 10 to the third, that actually makes this 0.001029, right? And if you think about what it says down here, it's a table value divided by 1,000. So at saturated liquid, the volume is this. At saturated vapor, the volume is 3.4. I'm 75% of the way between those two. So the equation I'll use to write that volume here is that volume equals the lower volume, which again is 0.001 10291 plus 75% of the difference between the saturated vapor and the saturated liquid, which is going to be 3.407 minus 0.0010291. So again, I'm 75% of the way between these two. That's the volume that I will be at. Okay, and after I do that calculation, I get 2.556 cubic meters per kilogram. Okay, so that's how I do interpolation. That's how I use my tables. Usually any two properties set my state. So I just use those two properties, figure out where in the table they are, and do my interpolation if I can't look them up directly.